All right, mathletes, here we are looking at the mid segments of a triangle. So we should be able to use these properties to solve for unknown measures. So let's look at a definition here. So what is a mid segment? A mid segment is a segment connecting the midpoints of the sides of a triangle. Okay, so let's go ahead and use GeoGebra, and we're going to construct some mid segments and try and make sense of this mid segment theorem. So the segment theorem says if a segment if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half the length of the side. So if I look at my GeoGebra here, okay, I'm going to go ahead and construct a triangle. Okay, so after I construct my triangle, I'm going to find my midpoints of each side. And let's just do it of these two sides. Okay, and when I construct my segment connecting our two midpoints, DE is the mid segment of that side. So what we want to notice is that as we look at and drag the different points around, that our DE is going to be parallel to our side AC. So no matter how, as I move this DE is always parallel to AC. Now the other thing said something about its length. So if we look at the length of D to E, okay, it's 2.1, and A to C, we see that as 4.1. So we know that it's always going to be half, the mid-segment is half of our length. So notice we can change it here. So we get 13, half of that is 6.5. I can change and I see that 6.8 and my mid segment is 3.4. So there's a good way of kind of seeing how our mid segment is always parallel to the other side and that it's always half of the length of our side of our triangle. So how can we use that to solve some problems? Okay. So here's the mid-segment theorem stating that we know that DE is going to be equal to half of A times C. Sometimes it'll be useful to write this as, instead of saying DE is equal to 1/2, I can say that DE times DE is equal to AC. Those two statements are logically equivalent, but sometimes as we're setting up equations, it might be more beneficial to use that second one. And then also notice that our DE is always going to be parallel to AC. Okay, so here I'm given some points, and we know that MP and N are midpoints of the sides. We know the perimeter of triangle MNP is 60, so we need to find these other measures. So the first other measure that I want to find is I want to find this NP. Okay, so triangle MNP, we know that perimeter is 60. So that I know that 22 plus 24 plus NP is equal to 60. So over here, I'm going to get 46, collect my like terms, plus NP is equal to 60. And when I subtract 46 from both sides, I'm going to see that NP is equal to 14. So now that I have that there, okay. So I have found NP. The next thing I need to do is find YZ. So YZ is this length over here. Sorry, I wanted to change colors. So that length there, YZ. So one thing I should notice is that YN is congruent to NZ because those segments are, N is the midpoint, so their two alternate segments are also equivalent. So if those are the same, then MP is the same length as YN because it's half of that. Okay, so if YN's 22 and Z's 22, so YZ is equal to 2 times our mid-segment of 22. So that is 44. Okay. So XM is this length here. So again, M is the midpoint, so XM is congruent to MY, which is congruent to PN because it's half of the entire XY length. Okay, so if I know that this is 14, this is 14, so XM is equal to 14. XP is this length here. So using the same kind of logic there, XP is going to be congruent to PZ, which is congruent to MN. And so XP is equal to 24. XZ is going to be 2 times our mid-segment, 2 times 24. So that equals 48, which is our XZ. Okay, so that's how we can utilize that mid-segment theorem there. Let's look at some other examples. So here in 2, okay, we know, so I'm going to fill in this in our diagram. So part A, if RH, so if RH is 7 and RS is 5, find ST. So if I want to find ST, I know that this RG is congruent to RH, which is congruent to ST. Okay, so then that means that ST is equal to 7. Okay, in B, okay, angle G is equal to 60 degrees. Okay, angle I is equal to 70 degrees. Find the angle GTR. What's that angle there? That's our unknown. Okay, so here, when we're talking about angles, we should have angle measures there. Okay, as we're talking about angles, we should be thinking how we can utilize our parallel lines, because you know with parallel lines that we can often tell things about angles and their transversal. So right now, I'm thinking about the angles that we know and the ones that we want to find. And I'm drawing the 2 parallel lines that we know. So mid-segment theorem says that we know that HI is parallel to RT. Okay. Well, those 2 lines are cut by a transversal. So that transversal is this GI. So when that transversal cuts through parallel lines, we get angles that either are congruent or they're supplementary. Well, 70 and our unknown angle are corresponding angles. So by corresponding angles, I can see that angle GTR has to be congruent to its corresponding angle of 70 degrees. Okay. Our last piece is that if RS, so RS, if this is x plus 85, okay, and GI is 3x, so this whole thing is 3x plus 46, okay, that I can do 2 times my mid-segment, RS, is equal to GI. So now by substitution property, I'm going to substitute in what I know for RS and GI. So 2 times RS, which is represented by x plus 85. So using my substitution property of equality, GI is 3x plus 46. So now I have an algebraic expression that I can solve. So I'm going to try and set up and keep my equal signs lined up. So first I'm going to distribute my 2. So I get 2x plus 170 equals 3x plus 46. Get all my x's on the right side, so subtract 2x, subtract 2x. So I get 170 is equal to x plus 46. Subtract 46 from both sides. And I'm going to get x is equal to 124. Okay. Last example we'll look at here. So find the values of our variables. So as I'm looking here, I can see that because of these segments here, I know that this is a midpoint. I know that this is a midpoint because these two are equal parts. Okay, so then that makes this a mid-segment. So then 2 times our mid-segment is equal to the parallel side. So as I solve that, that's 6x equals 84. Divide by 6, divide by 6, I get x is equal to 14. Okay, using that same logic, I can say that here's a midpoint, so this is a mid-segment. So if I do 2 times my mid-segment of 4, that'll equal its parallel side. That's 8 equals 5x minus 2. Add 2 to both sides. I get 10 equals 5x. Divide by 5. Divide by 5. X is equal to 2. That concludes our notes for today. Please highlight any questions you have and bring them to our office hours.